Hi, my name is Karen Gleason. I am a professor of chemical engineering at MIT and also now the associate provost overseeing space renovations and industrial relationships. In my research, we're really looking at modifying surfaces in ways where we have nanoscale thicknesses, but these ultra-thin films can be scaled over large areas and economically. It's really a platform technology. We've already had 2 companies spin out from this. One, GVD, has commercialized this for over 10 years now, and Dropwise, which is a new company that I co-founded with Kripa Varanasi, a professor in mechanical engineering, came out last year. And we're really looking to extend that platform to other areas. Current areas that are of interest are desalination of water, which is just a critical problem. The world really needs access to fresh water. And we find that the membranes that are used to desalinate the water in a process called reverse osmosis can be dramatically improved by adding an ultra-thin film to their surface. The rate at which the salt and the water are separated remains the same, but what the surface is able to do is prevent fouling of those surfaces by molecules and microbes. And as those membranes get fouled, their performance goes down, and eventually they also have to be cleaned. So there's a cost for maintenance and a degradation of the membranes when they are clean. So we'd really like membranes that are maintenance-free that would be able to provide us fresh water. So this is one big area that we're working on currently. So all of the surfaces that I do are organic materials, and I've chosen consciously to focus on that. And we're really relying on the techniques that have been traditionally used for inorganic materials and are widely used in the semiconductor industry and known for their purity and scalability to make integrated circuit after integrated circuit. And by opening up these processes for organic materials using some tricks of the chemistry, we have the ability to do that for a wide range of new classes of materials. The first things actually that we took commercial are fluorinated materials, which have been notoriously hard to deal with from solution. So having a vapor phase process has made them very attractive. And this first commercial application went to a company I co-founded with Dr. Hilton Price Lewis, GVD, and there the fluorocarbon is actually applied to the molds that are used to do rubber manufacture, in particular manufacture tires. And this ultra-thin coating can go over all the treads in the tire molds without any problem, is very durable through the tire molding process for periods of months, and provides economic advantage because you're not always spraying the surfaces of the mold with something like a silicone release oil, and it has the ecological benefits of not putting all those solvent-based sprays into the atmosphere.